The people who will miss the first part, probably they can see the recording then. So I hope my screen is visible and I am audible as well. So can you just confirm it once?
Yes, sir.
Okay, so today in the first session, so we'll be going over the basics of what actually artificial intelligence means and what is the meaning of machine learning and deep learning. So before that, I would like to introduce Sanmit, which I have already posted a message on the group regarding him. So other people are also joining, so I'll just admit them. So before going ahead in the session, I would like you all meet Sanmit, and because he will be the head of teaching assistant, so he'll be grading your projects and he'll be giving you the feedback. Can we have some small stuff on probably if you can ask him questions as well, that will be good. Sanmit, over to you.
Assalamu alaikum everyone. So I'm Sanmit and I will be the head of the teaching assistant team, and I will be checking your assignments, the programming assignments that you are getting. You will be getting in some time. So I will be checking those, and also I will be like giving some personalized feedback on everything, each one. So that is the plan. And so like to take the best of this course, you have to really like do genuinely good, and genuinely you have to invest some time and effort. And also so it is something of a very emotional side to me. So I am actually a new convert to Islam, Bengal. And so thing is that I see in my non-Muslim circles, in my parents, in my like in my non-Muslim relatives, everything, the Islamophobia that we see, that stems from the bad societal image that the Muslims have. So we have to really ask ourselves that are we doing enough to uplift this image? Because like let's say we see the West, we see the Human Development Index, we see the lot of indexes that they have made up. So we look up to them, we look up to the West. So we take those indexes, we like to imitate their lifestyle, everything we take. But in the case of India, if we see the Muslim community, it is poor, it is educated, and due to these scarcity and poverty, it is the Muslims of India are forced to be involved in some unlawful activities. So that's why we are not looked in a very good way. So it is our responsibility as Muslims to uplift this image, because it is only possible. It is not possible by only by theoretical knowledge, but it is all has to be done by practical implementation of your education. You have to see the education as something that will be taking you up, taking you outside of this suffering or oppression. And so you have to really invest your time in a genuine fashion in this education. And also, so if you see that in the day of judgment we will be asked about, okay, so probably Allah will say that what did you do to uplift the image of the ummah in the name, in the eyes of non-Muslims? What did you do? So then we will have to answer it. So for that the effort starts here. So you have to be really best in your capabilities, and you have to give your best in this course, so you learn more. So India, for example, for India, when it was colonized by the British, then it, and many Indian people went to Britain and other European countries, then they got educated, they came back to India, and then they fought for freedom. So if you have to fight for your freedom, if you want to be like, live a good life, a good independent life as a human being, as an individual, and as a society, so you have to know how India works. You have to interact with India, the education system of India, technological environment of India. So by that only you will be getting to know India and how it can harm you, and how it can you can escape that. So this is the course for everything, and thank you for this. I am very grateful to be part of this.
Actually, I'd
So
like everyone to congratulate him because he has just converted, I think, 6 months back into Islam, and previously he was a Hindu back then, and then Allah guided him to the path, and he was really kind to help you guys, giving the feedback, because he has that intention of creating good impact in the society and to contribute towards the Muslim Ummah. Because as he said that at every index level we are performing below the par. So maybe you can give him a message, or somebody has to say him some good words, because we welcome him into our Ummah and into our community as well. Thank you, Sanmit.
Welcome.
Assalamu alaikum. Musa, just a few words for the Sanmit. Musa knows I'm not in a position to speak, but I have to. First, Sanmit, Assalamu alaikum. We are glad to have you here.
Salam.
I would love to meet you one day, inshallah. I have been listening to you right through from the go you started your speech. As Musa knows, I'm not in a position to say more. Just want to say you thank you for being part of this, and I would love to meet you one day. Thank you so much.
Welcome.
Yeah, I think we should get started. Sanmit, you may have some other things that you can leave the meeting now, because I'll be teaching these people, so you can go ahead with the plans that you have.
Sure.
Yes.
Thank you.
Okay,
Salam alaikum.
thank you so much. Walaikum assalam. So is everyone hearing me? So screen is visible because I'll be writing some things on the screen, and I want this to be an interactive session, as I said in the previous sessions as well. So Zubair, am I audible to you?
Yes, sir.
Fine. So in this session, the first thing that we will go is we'll see what is meaning of the AIML, what do we mean by artificial intelligence, and what is machine learning, and then what is deep learning basically. So we'll go on these, learning about these terms, then we'll move on to the history, how it all started. So I'd like to start everything because they're in this artificial intelligence. Can anybody just give his comment on what is meaning of this word intelligence? Any comments, like if you have any thoughts on what do you understand by intelligence? Then probably you might know what is artificial. Artificial means it's induced effect, it is not natural. So Umar, you wanted to say something? You are not audible actually, you are not audible properly.
It is the ability to learn or understand to deal with new things.
Right. The ability, so the definition he gave is it's the ability to deal with the new things by, for example, if you see something and you have ability to adapt to those conditions. So that's what we mean by intelligence. And sometimes we perform the tasks that we haven't done, and we see some person doing a task, and we learn from it. So that's what, in a broad sense, not in a formal sense though, it is intelligence. And somebody even commented something, so I'd also see his message. So Muhammad Faiz said that capacity to do work on itself. It's also a good definition, fits this, that if somebody, without being explicitly guided, okay, do this, he's able to make his own decision, or a machine, for example, it's able to make his own decisions. That's what we actually mean by intelligence. Actually, there are formal definitions of intelligence as well, that we won't be going into deep, because then it becomes a philosophical question. Okay, what do you mean by this and that? So by artificial intelligence means, like, initially if you see, humans had to do everything. So if you see here, what we have defined as any technique that enables computers to mimic human intelligence. So intelligence means that they should do the things on their own, as somebody said, that capacity to work on itself. So here we have mentioned it, any technique that enables computer to mimic human intelligence using logic and other rules. This includes basically the artificial intelligence. So anything that a human is capable of doing, if we make a machine like that, so that it's able to do the same task without being told what to do, like exactly the steps. For example, if you talk about algorithms, like usually we have algorithms. So in algorithms, what we do is we'll write step-by-step guidance. If we have to make a cup of tea, for example, we'll write step 1, do this, step 2 and step 3 like this, and we'll give a step-wise procedure. That is actually not intelligence, because you are guiding some particular thing, probably a machine or a human being. That's not being intelligent. By intelligence, I mean that the machine or a human should be able to do it on its own. So that's what I mean. Here, artificial intelligence, it means all those techniques that enable, particularly computers, to do something on their own without being explicitly told what to do. And then comes the machine learning. We'll see why these things came up, and it actually has a historical deep learning, and we'll see that. So first I would like on the screen, let's say we have a problem to solve. If you are working in a banking sector, a lot of transactions, there are people who do fraud transactions. For example, they'll do some tinkering with the system, and with that system they'll try to do a transaction which is actually illegal. So we have to detect those frauds in the machine. For example, if we have this transaction data, and out of these transactions we want to know that what are the transactions that have committed fraud. So in that, one approach is that we'll write a bunch of rules, basically the program, and that will find something in. For example, let me take a small example, simpler example. Even if I am given two numbers, like I am given number 1 and number 2. So my task is to sum these numbers. This is my task at hand. So in the traditional programming, what we basically do is we'll just write a set of sequences, basically the steps, which we call an algorithm, which will take these two things as input, and then that program which I will write for the machine as an input. So this will go into the machine, and it will give output as the sum of these numbers, number 1 and number 2. Am I clear?
Yes, sir.
So what I mean by is, for example, if you have a task in your hand and you want to write a program, so for that you have to the computer. If you see here, we have a computer. To this we give this data, transaction data, for example. This is actually data on which to operate, and then we give rules, basically the program is not a set of rules. Algorithm is just stepwise, some steps which the computer understands. Then this computer will manipulate, this machine will manipulate it and provide whether a transaction was fraud or not. In the similar scenario, if we have some other problem at hand and we want to create a program for that, if you see, most of the things that you do is basically done by this traditional programming. If you want to make a website, so for that you have data, you have the text as your data, and then you write a program how to process the data. This data and this program, this goes to your machine, and then this machine produces some output, for example a beautiful looking website or something like that. But that's the traditional approach to programming. And if I can tell you, okay, can you write a program, for example, for a thing which if I give it image, it should detect, for example, it should differentiate between cats and dogs. Let's say I have some data in which we have cats and dogs. Okay, so I want you people to write a program for that, which this data and that program will go and will be fed into the machine, and then machine should differentiate whether the image was cat or dog. Okay, so if you do anything like that, you have data and you want to manipulate their data based on the programs humans have written, based on the explicit instructions that you give to the computer. That is the way how traditional programming is done. If you are even familiar with some basics of programming, there you will write a program, then some input you will give to the data, and then computer will sort of do some manipulation of the data and produce a result. So how does this machine learning or AI does the work? It actually is the reverse process of that. So what we do is we'll first give it the transaction, we'll give it the data, and we'll give it the goal. Okay, what is the thing that we want to do with the data, and then it will come up with some rules. So by that I mean, if I again take that data example of these cats and dogs, I'll just give a bunch of example of cats and dogs. I'll feed these cats and dogs, and I'll feed also these labels. For example, in a setting where we call it a supervised learning setting, we'll give some additional features like we have this is a cat, this is a dog. We'll train it on multiple examples. Then this machine will learn the rules. Okay, maybe cats have more stats, dogs don't have. Cats are smaller in size, dogs are bigger in size. So this machine will spit out the rules basically, and then by using the rules, and this usually is called a machine learning model. So when we get model out of this, then when we have this model, then we'll just give it to the data, and it will give us the output that we want. Is the differentiation clear between what's the difference between the traditional programming and the machine learning? Like in a broader sense, in traditional program, what we do is, the basic thing is that you will give the data, you will give whatever you want to manipulate, basically the input I'll say, and then the rules, the program, the algorithm, and you will feed both of these into the machine. Then machine will act on that thing, the data, by using those rules, and it will manipulate and try to come up with the desired result that we want. But machine learning is completely reverse of this. First we'll give it data and the outputs as well, the desired outputs. For that's why afterwards we'll feed that into the machine, and then machine will come up with the rules. It will basically come up with a program that will do that. Okay, So to just write it over here, I'll just, for example, this was the machine. Initially it was fed with the data and the objective that we wanted to achieve. So here it gave this machine, it gave us actually the rules, which I told that it is called the machine learning model. Then these rules, we will input some unseen data. By unseen data, I mean that the data that was not used when we generated that program. And this data, when fed it into these rules, and it will give us the output. So you can clearly see there are two phases. There are two phases in this. The first phase is this phase, where we give the machine the data and the objective that we want to achieve, and by machine analyzes data by using the machine learning algorithms. That algorithm we will learn in the course, and then it produces a set of rules or some program which we call a machine learning model. That's the first step. Step one. Step one is that we actually make a model. And in making of the model, there are multiple steps involved. As you see, we feed the data, we give it an objective, then there are algorithms running, and then it comes up with a model. That's the step one, broadly speaking. The step two is that by using this model, we'll again feed it the unseen data that was not given it before. Then it will come up with an output. The first step is called the training phase. And the step two is called the testing phase, or the inference part, in which we infer something. Okay? Am I clear till this point? Okay. So if anyone has a question till this point, you can ask me, like, okay, I am not clear with the training, testing. You can just interrupt me anytime, huh? I don't want this to be just a session where you guys don't interact, don't ask me questions. So I'll just reiterate the things. The first thing, if you see that there is a difference between traditional programming and machine learning. In traditional programming, we have some input or data on which we want to manipulate this data and produce some output. For that, we'll write our own programs, our own steps, our own rules, and give it to the machine or give it to the computer that we want, and it will give us the output. In the machine learning, I broadly told that there are two things happening. The first thing is training phase. Training basically means when you have data and you have the objective as well in your mind. This basically, if you ask question to yourself, in the when a child is born, how does he learn? He basically learns by using this. So, for example, he sees many other people around him. So he then he or she, after a while, after 6 months, after 10 months, the brain continuously takes the input from the environment. He or she sees his or her mother, father, and then he's able to identify after a while that this is my father, this is my mother. Basically, that is basically the training. And in artificial intelligence, as I told you, we want to mimic the human brain, how actually human brain works. Similar thing happens here. So we are in the first training phase. We give data and the objectives as well. That this is the thing that we want, and then machine learning process that finds some pattern and then gives a machine learning model to us. And based on that machine learning model, we'll give it the unseen data. And on the unseen data, we want to predict something. Again, let me take a concrete example of that. For example, let's take example of the weather. Okay, in weather, we have data, for example, of previous, let's say, 2 years. For each day, there is a temperature, max temperature, minimum temperature. So we have that. So you cannot come up with the rules. If you want to write rules, then you have to measure everything. For example, you'll measure precipitation, humidity, and things, and make a program. If precipitation is this much, then probably there is a percentage of chances of rain, and then you'll have a number of factors in that. So these number of factors will decide whether it will rain or not. The other approach is that by using that data or even the previous data that we have, we'll come up with a pattern and we'll ask machine to find the pattern in it. And by using that pattern, for the next day we will be able to predict something. So things like that we'll be handling in the machine learning. So this artificial intelligence part is clear. We wanted to see are there some techniques, can we come up with the techniques which will mimic sort of human brain and human intelligence. So historically, how it started. So if we go really back, it started in Greece. They wanted to make intelligent machines. If by intelligence you mean to sum up two numbers, then we have a calculator which does some intelligent thing and faster than humans. The first milestone, I'll say, was done by Alan Turing. How many of you have heard this name, Alan Turing? Nice. So Alan Turing was the first guy who came up with a machine that was known as Turing machine. I hope that you are also taking notes. So Turing machine, it was actually whatever your modern computer can do, the Turing machine was able to do that. It has a beautiful story behind it, how these machines got created. Let me just briefly tell you the story, what happened and how this machine came about into existence, and why. Actually, there is a saying that necessity is the mother of invention. So if there is something is necessary, then we try to invent something. So similar thing happened with the computers and machines that we have today. The first thing that we had is there was a war going, probably in the Second World War per se, or First World War. Something happened. So Germany and USA was in the war, and Germany has invented a machine known as Enigma. So what the Enigma could encrypt the message. I think you know the word encryption. By encryption, I mean, for example, if I speak something, I'll just scramble the words here and there. I'll make it in such a format that so that nobody understands. I'll basically multiply or something, do manipulation of something, and on the other side, other person will be able to decrypt it. So that's what I mean by encryption. People usually who have some exposure to cryptography, they might know these terms. So Enigma could actually encrypt messages and then decrypt them back. By encryption, I mean a form which is not understandable. By decrypt, I mean to get the original form back. So in Enigma, what we did is, so when the Germany had to attack the US, they sent the coordinates basically. They sent today on this location we'll, for example, drop bombs or do something. All of this was done in encrypted form. So even you could have listened, and as radios were discovered that time, you could listen to these waves, but you are not able to make any sense out of it, because it was just a jumbling of words, just some noise coming. So what US thought, they thought that we'll bring some brilliant mathematicians together, and these mathematicians probably will be able to solve these problems, and they'll be able to come up with the rules, and they'll try to decrypt this, the Enigma's code basically. But after a lot of trials and errors, they couldn't. So Alan Turing was one of these mathematicians. So Alan Turing, what he did is, he thought machines can only beat machines. If it is a machine which is encrypting it, probably we should come up with a machine which can decrypt it. So in that pursuit, he started creating a machine which can decrypt those codes. So he came up with this Turing machine, and Turing machine was the first milestone which was done in modern computing. That's why Alan Turing is sometimes called as father of modern computers, because he was the one who gave the shape to the modern computers, and it started from there. And he has a beautiful paper, Can Machines Think? If you want to differentiate between machines and humans, there is a thing called as Turing test, so which can easily differentiate whether you are speaking to a machine. I just urge you to look at it, Turing test. This is how all of this started. So the computers now came into existence. Now we can do the tasks on the computer. Okay. So what was so spectacular what the difference basically between these machines and humans? Why were they fundamentally different? The fundamental difference that you can even identify is that even if you look at the machines, the problem there was machines could do the tasks which will take humans a lot of time. For example, if I give you 10-digit numbers to add to multiply these, it will probably take us few minutes to few hours even. If I give you some problem like the things that is I'll tell you, solve this integral, solve this differential equation, or do a computation. Humans were really slow at that, but if you see, machines were really fast at that. If you give a calculator just two numbers which are probably 8 digit or something, it will do it in nanoseconds. The things that machines were slow, humans were slow at, machines were really fast. The machines were fast and humans were slow at some tasks like computation. But whatever we see, for example, जब हम देखते हैं, I'll speak. Is everybody okay with Hindi? Zubair, are you guys understanding Hindi? Because I may mix Hindi and English sometimes. Huh? Okay.
Yes sir. Yes sir.
Thank you for confirming. So I'm saying कि अगर हम ऐसे देखें कि कुछ चीज़ें ऐसी थी जो बहुत humans के लिए बहुत मुश्किल करना थी, जैसे मैंने computation बोला, if you want to do some computation. But some things were really easy for humans. For example, if we have to detect whether it's a cat, or if we given an image and ask that if it's a cat or a dog, then it's really easy for us to, it was very intuitive. So that's actually really hard for the machines. So that's the fundamental difference we want to understand that. So then a lot of things came together. If you see we wanted to mimic human brains and think like that. Okay, why are these machines not able to do the fundamental tasks which are really easy for humans but very difficult for machines? So then the machine learning approach came in. Like we wanted to make these things that we are easily able to do. We want the machines to learn them. हम basically ये चाहते थे कि machines ऐसा काम क्यों नहीं सीख सकते. The first problem there was we couldn't formalize it. हम बता नहीं सकते थे ये चीज़ें हम करते कैसे हैं. So the best thing is we couldn't formalize it. तो हमें इसको formally बताना पड़ेगा पहले. So if I will ask you a question, how do you add two numbers, for example 20 and 30? You will just easily say, you'll say, let's take an example. If you have 20 less apples and then you have 30 apples, you put them in a bag together, then you count them again, you will get 50 apples. It's really easy to formulate it. It's really easy to articulate it. But if I ask you a question, how do you differentiate between a dog and a cat? I think it's very difficult to tell how do we differentiate between this. And even if I ask you the question, how do you differentiate between your friends as well? For example, मैं जुबैर और जहांगीर में क्या difference कर रहा हूँ? So if both of these faces are there, मुझे खुद नहीं पता कि मैं ये difference कैसे कर रहा हूँ. It's very difficult for us to formulate it, to articulate it. That's why we cannot make some rules कि ये चीज़ें अगर मैं rule based, क्योंकि मुझे खुद भी नहीं पता कि how my brain works. So in that pursuit, we wanted machines to learn these things, the things that are intuitive to us but difficult for machines. That's why the first thing came knowledge-based approach. So what they did is they came up with formal logic. They came into formal logics, like we have something called as prepositional logic, predicate logic. They don't need to understand though. So we came up with these machines and we tried to formalize these things. And for example, Psych was the machine that was made, and it actually was near to nowhere near to machines nowhere near to humans that we have actually. So this Psych machine was basically on this formal logic, but it was not performing really good. Then there is why this ML comes into existence. So हम लोग ये चाहते थे कि हमारे पास कुछ data है, we will find the patterns. तो ये pattern find कैसे करें? Then this ML came. And if you see, there has been lots of going on. For example, if we see this, I have written Shannon's min-max checker. There's a game called like checkers. So Shannon क्या था? तो Shannon wanted to make a game. So what he did is he wrote some rules, and he wanted the machine to automatically find some good moves and good things out of this game so that it can beat a good player. So he was actually to some extent able to achieve that. Then in 1957, Frank Rosenbelt, he created Perceptron that will also look. I'm just saying like the random stuff right now to put it in the historical sense. In the Shannon's game also what happened, so he made these computers in such a way that these will play against each other. So उसके पास एक computer 1 and computer 2. So what he did is he told them to play towards each other. और in that play they'll gain some experience और उससे वो बहुत अच्छे हुए. And Shannon didn't knew that कि ऐसा कुछ होने वाला है बहुत खतरनाक. So what happened there is, so in that thing he made these games in such a way that it could easily beat the best known players at that time. So then they thought कि हाँ there is very really some effective ways in which we can make machines learn and they can even beat humans. Then when Frank Roosevelt came with the Perceptron, तो बहुत सारी claims market में आए कि humans will be going into the wars, will have waiters as these machines. These machines will be able to go into the wars, and machines will be able to do everything that actually humans are able to do right now. But then came a paper by Minsky and Peppert in 1969. So in that paper they mentioned that, for example, mapping of an XOR gate cannot be done by this Perceptron. So every funded was stopped for this AI. So you got the point. So there is something called as AI winter. So if you see from 1940s, 50s, you will see there is a huge buzz about this artificial intelligence. Everybody was talking about it. So this can be done, this can be done. Then these two scientists, they came up with a simple task, which the machines were not able to do. So they were like, the Perceptron that we have currently, it is not able to do this. So how are you claiming that it will be able to mimic every human intelligence? So every funding that was given to the AI people, that was stopped basically. So this is what he is meaning by the AI winter. There's a whole winter of AI. So no research was conducted. Probably people from here and there, they were conducting some research, but mostly the funding was stopped. And this is how actually the fields come into existence. If I have to give you a broader sense, तो ऐसे होता है when a new topic comes in. Many other people जो बहुत सारे forefront पे होते हैं, they put money into that. They ask scientists to pursue these careers. For example, as I said right now, I myself am working on quantum computers. But quantum computers are nowhere near at least till 5-10 years. So we basically don't have hardware. But still we are putting our efforts to come up with the things that we'll do with these quantum computers, and some hardware people, they are coming with the quantum hardware, because there's a lot of funding in this quantum computation wala part, because it is showing some really good results. So that's why people are giving the funding. If somebody came up and said, no, this quantum computing is not worth pursuing, then probably our funding will be stopped. So this research will get impacted badly. And the same thing happened with AI. So AI was creating a lot of storm in the market in 1950s. Then when these two came up with the paper, then suddenly AI funded stopped, majorly it stopped. And that's why we see this AI winter. Then came in nearly in 2000s or so. So the Hinton came. Hinton then published a paper on deep learning. So then they showed the possibility that what we can do. And then again this AI wala thing, it took a boom. And now the thing is, they changed this name of AI into machine learning to get funding basically. If you ask me why was this AI changed, the name of AI changed to the machine learning, basically to get funding, because this AI was taken by that thing. Like there was a winter, AI won't be able to do something. So they called it a machine learning. That's why I'll go to the previous slide back. So artificial intelligence, you understood the broader concept, how it started. Then why did we consider machine learning? Actually, it's a subset of AI. In AI, it was a broader sense. So they said, we are not doing everything is possible, like we'll make a human like this, but we'll use some statistical techniques. If you see it here, I mentioned, we'll use some statistical techniques. Okay, that will enable machines to improve. We'll use some techniques in the statistics and probability mostly, and these techniques will be used to make these machines better, to take better decisions, to predict good things. So that's why they renamed it as machine learning. Okay, machine learning, it was actually really cool because it was bottom up. By bottom up, I mean we'll work on machines to create the humans. It's not like in AI it was top down, like from the humans we'll learn everything, then we'll create machines like humans. So if you see this approach, it was top down. By top down, I mean a human was at the top scale. Okay, we wanted to create something like humans, and then we were going down the line to create humans. But if you see this machine learning, it was bottom up. So here we said, we'll use computers and we'll do some small tasks. For example, identifying a cat and a dog, identifying handwritten digits, maybe doing some amazing stuff, and slowly we'll run up and we'll try to mimic human behavior. We'll try to mimic humans. It's not that in altogether what a human does we'll do that. Now you understand the point. What was the difference between, like, broader difference between machine learning and AI? Do you have any questions? Or even I'm audible to everyone?
Yes, sir. Yeah.
Okay, so if you have a question, you just ask me. I'll just drink some water. That's a historical perspective I wanted to give. Why did I started with Turing? Then there was a lot of claims. Then came the AI winter and stuff like that. Somebody raising hand? No. Okay. So then came the deep learning. Deep learning, actually, it was proposed long back, the perceptron model and the things like that. And this deep learning basically tries to do what what the biological humans do. For example, if we have a neuron and they're intricate, there is a lot of theories. We'll also go into deep into this neuron, and we'll also go deep into this deep learning stuff as well, because now we'll have some layers. That's why it's called deep learning, because there we will have some layers called as hidden layers of neurons. So you'll see something, you might have seen some architectures like this. So there are some layers like this, and that there are some connections like this. So these things are, for example, called input layers, and then we have something called as hidden layers, and then we have an output layer. Let's say there is a one neuron, and these things are called as neurons, and then we have activation function. A lot of stuff goes into deep learning. If you see, this is a Venn diagram that I have made here. Artificial intelligence, it's a big umbrella term. So in that, this machine learning is a subset. It basically contains a subset of what is there in artificial intelligence. The deep learning is again a subset of machine learning, if you see it. Okay, and deep learning is really expensive nowadays. If you see these large language models like ChatGPT, they are based on these deep learning things, because we have a lot of parameters, billions of parameters there to tune, and we learn about what these parameters mean. In a broader sense, I wanted to get you this, like artificial intelligence was a word used in 1950s, then there was AI winter, then people changed the name to get the funding basically to machine learning. And machine learning basically was a subset of things. and then came the deep learning. In that, we wanted to basically mimic the human brain. Whatever human brain, how is it doing basically? There is something called a reticular theory. There are a lot of theories. So that's how it developed, this subject developed. Okay, then in this game, even like there are algorithms which can teach itself. And if you see, IBM also created that's known as Deep Blue Chess in 1997. So this game was able to beat the best player of the time in the chess. And now we have these games like chess games, even which computers can play, and no human on earth can actually beat them. And if you recently see, there's a game known as AlphaGo. AlphaGo is a really complicated game than this chess. So AlphaGo, and there were best players. So I think it was made by DeepMind. So DeepMind came up with a model which can play this AlphaGo better than humans. And it was a very emotional story for these people. And the best in the world guy, he lost I think 4 matches out of 5 by using this game. And let's see, where is this ML now? Where is this machine learning AI now? So that's the thing I want. Can you just give me examples where are machine learning being used right now? So do you have some things in your mind? I think here machine learning is being used. So what do you think? I'll just call out random names probably. Amir, will you be able to answer like where the machine learning is being used now? You can just, it might be predictions. I actually want a specific example. For example, it is using in Amazon delivery. I'll say it is using in recommending systems. It is using in some other things like that. Yes?
Search engines.
It's using search engines that I have written in here. I think you saw that. Cancer detection.
Yes, sir.
Cancer detection is also a good thing. Yeah, it's also used in cancer detections. Okay, some other inputs, because I want you to interact, not just write. Can you please unmute and just say if it's used in here? YouTube recommendations.
Stock market prediction.
It's also used in stroke predictions. Stroke predictions.
What is stroke prediction?
The model which is taking input from the people and generates the output.
No, what is the stroke basically? You said some stroke prediction. I am not aware of strokes. What strokes is?
Stroke disease, actually hypertension. We can say that as we can take another example of heart attack detection.
You mean in a broader sense disease detection basically, like okay, targeted advertisement. There are a lot of things coming that you have at least some understanding of where it's used. The first thing it's used in search engines, I'll say. By search engine I mean if you can see Google, if you can see Bing, I mean YouTube itself is some sort of search engine. It is used in there because they have to target you with a specific web page. If you are searching for something, they want to give you the relevant search. अगर तुम कोई चीज़ सर्च करे फॉर एग्जाम्पल गूगल पे और जो तुम्हारे relevant नहीं है, then there is actually no use of that search engine. So it's used in there. So basically they take where do you live, कहाँ पे तुम्हारा location है, and then probably the age as well. तुम्हारी age कितनी है, तुम्हारा sex कौन सा है, and then based on this information they'll give you the related content. And even they take also religion, वो vicinity भी देख लेते हैं वो लोग. So all these things, if for example you are living in the similar location, you will probably get one result. If there is the same guy, he's asking same thing to the Google, he'll get some different results. This is basically the power, how they use, how the search engines are being used. Then have you heard about spam filters? Anyone? What the spam filters are?
Yes, I think it is also available in emails. The spam emails.
Right. So what spam means, for example, if you get an email, sometimes some companies or even some fraudsters, they try to spam people by sending the emails which have of no use, and probably they want to trick somebody in buying something or something, and they will send you the emails. So it's really a hard task to actually differentiate between the actual good emails and the spam emails. So here the machine learning comes in. We are making some spam filters. I'm getting some message. I think somebody got disconnected. No. Okay. So what I'm saying is that in spam filters, the task at hand is that if you are receiving an email, you have to tell that whether this is a genuine email or some spammer is trying to sell me a product or do something. For example, take my bank IDs. You might have seen there are some phishing attacks done as well. They send emails and there are links where we click and then they take our data as well. So then we are here, we use machine learning to differentiate between these good emails and the spam emails. So there is also where we use it. Then news, in today's news, if you read articles, for example, on Hindustan Times or something, they also use this news. They give relevant news to the according to the person. For example, if you ask them you are interested in sports, so they'll more recommend you the sports news. तो वो ऐसा करते हैं, they won't be much bothering about the political stuff and other things which you might not be interested in. तो वो ऐसे recommendations देंगे जो तुम्हारे लिए हो, that's tailor made for you. So news, again, if you see the recommending systems, like who doesn't watch Amazon, YouTube, Netflix and stuff in there, and then you get even the YouTube has the best recommendation, Netflix has even better than that. You can see that if you watch some video, तो उसके बाद एक ऐसा video आता है again that you would like to watch probably. So these recommendations are recommend systems, they use these deep learning, machine learning techniques. And then these self-driving cars, if you have really heard that Tesla has created some self-driving cars, the company actually owned by Elon Musk. So all of these things basically they use machine learning, and I don't think nowadays there's a company which does not use this machine learning, deep learning, because of this peer pressure, because of the FOMO effect. Basically they have to take it because other companies are doing it. So to be in the market, to do the competition, to be in the competition, if you know when the ChatGPT was released, ChatGPT was released by OpenAI, if you know them. OpenAI is a research group. So OpenAI, when they released ChatGPT, so this was then acquired by, so OpenAI group was acquired by Microsoft. So they, I think if I remember correctly, they gave them $43 billion. These many dollars they were given as a fund. Like it still is somewhat like an independent organization, but most of the shares are with the Microsoft. Because Google's most of the ad revenue, Google's business model was they were making money by ads. If you see YouTube, there are ads. If you see Google, there are sponsored pages. So Google actually was threatened. The whole existence of Google was threatened. So Google को ऐसे लगा कि now they are making this ChatGPT which can give tailor-made suggestions and things. Our business is gone. So if you know that, they set a red alert in their company. So all of my friends who are working in Google and my seniors who are working in Google, they're asked to come to the Google. Before that, they were asked to, okay, you can work from home. But when this OpenAI wala stuff ChatGPT came, I think for nearly a month, the red alert was there. So for this period of time, all the employees were asked, no, you come in the offices, otherwise like we'll probably lose on something. Then they come up with the BARD, if you know, and it was a disaster basically. They came up with the BARD and it dropped their stock market and things like that. The broader concept I want to give you that there is no company right now on the face of earth which I know of which is in the IT domain and they are not using AIML. That's why there is a high demand of people who know data science, who know this machine learning and deep learning. So I think I gave you a perspective. Now I would like to go into the formal definitions of this. I'd like to also take questions if you have some questions. Is everybody understanding whatever I am saying? Is everybody understanding? Everybody comfortable with that? Nice. So the first thing, now we want to formalize this learning. तो अब हम पहले खुद पे क्वेश्चन करते हैं कि ओके व्हाट डू वी मीन बाय लर्निंग, हम लोग कैसे सीखते हैं. तो इफ यू टेक ए ह्यूमन, अगर हम ह्यूमंस की बात करें तो ह्यूमंस कैसे सीखते हैं, हाउ डू ह्यूमंस लर्न. सो ह्यूमंस हैव टू डू सम टास्क. ओके, फॉर एग्जाम्पल अभी तुम मेरे से कोई मशीन लर्निंग चीज़ पढ़ रहे हो, दिस बेसिकली लर्निंग इज अ टास्क. तो हम वो चीज़ कर रहे हैं, मतलब हम कोई चीज़ सीखने की कोशिश कर रहे हैं. चीप नंबर, somebody is making a message, I'll look at it later. So the task at hand may be, for example, we are learning to eat. A small kid or a small child, वो एक बच्चा सीख रहा है कि खाना कैसे है. Let's say this is the task. The first thing is he'll walk, he'll eat some things, or if he is learning to walk, these are two tasks at hand, eating or walking. If human wants to learn these things, तो वो क्या करेगा? So from the first thing is he has a task defined. अब वो now he'll perform some steps, go here and there. So he'll gain some experience. Okay, so जब हम कोई चीज़ करते हैं, for example, if I have to eat, first I'll try, okay, ये हाथ में मैं कैसे ले लूँ मैं, or should I take the spoon? So I have to make some decisions. Okay, spoon लेना है, हाथ से खाना है. Okay, then I'll say probably my hand is better. So I actually have an experience. I did something, some random thing, and then based on that I got some experience. और फिर मैं वो एक्सपीरियंस मेजर करता हूँ, डिड आई बिकेम बेटर एट दैट थिंग. अगर तुम बच्चे को देखो खाना खाते हो वो बहुत सारा खाना गिराता है, बट एज टाइम प्रोग्रेसेस वो ज़्यादा सीखता है इन चीज़ों के बारे में, तो वट उसके बाद वो कम खाना गिराता है. विद द टाइम ही गेट्स एक्सपीरियंस हाउ टू ईट इफेक्टिवली. एंड देन इफ फॉर एग्जाम्पल ऑल ऑफ अस आर एडल्ट्स एंड वी प्रॉब्ली डोंट स्प्रेड द फूड, तो हमारे पास बहुत ऐसा एक्सपीरियंस आ गया है कि हम लोग खाना अच्छे से खा पाते हैं. So that's how actually computers. This is the definition by Michel. He's a really good computer scientist. He gave this definition to formalize it. He said a computer program is set to learn from experience E. I'll just highlight these terms. A computer program learns with the experience. We will call that experience E. Similar as the human learns with experience, a computer also learns with the experience. With respect to some class of tasks T, as the computer is doing some tasks, as I said कि ह्यूमन भी जो टास्क कर रहा है, लेट्स कॉल इट टास्क टी. विद एक्सपीरियंस वी लर्न सम टास्क टी एंड अ परफॉर्मेंस मेजर पी, बिकॉज वी हैव टू ना मेजर द परफॉर्मेंस कि सही में बेटर. अभी मैंने क्या चीज़ बताई यहाँ, परफॉर्मेंस जो हमारे ईटिंग में कौन सा परफॉर्मेंस था कि हम लोग खाना कितना गिरा रहे हैं, प्रॉब्ली द वे ऑफ ईटिंग. आई से जितना खाना कम गिरेगा दैट मीन्स कि आवर परफॉर्मेंस इज इम्प्रूविंग, अगर वो ज़्यादा गिरा रहा है दैट मीन्स आवर परफॉर्मेंस इज डिक्रीजिंग. ओके. And the definition says that a computer program is set to learn from experience E with respect to some class of tasks T and performance measure P. तो इन चीज़ों को मद्देनजर रखते हुए अगर तो उसकी परफॉर्मेंस जो है वो इंक्रीज हो वो इस टास्क पे, यानी कि परफॉर्मेंस विद एक्सपीरियंस जो है वो इंक्रीज हो रही है. सो बाय सिंपली वर्ड्स आई मीन if with the time if I am measuring something by a performance factor P at on some task T, अगर वो एक्सपीरियंस E के साथ साथ उसका परफॉर्मेंस बढ़ता जा रहा है, then we say that this program or this human is learning. This is the formal definition basically. This is the formal definition. That it'll take you some time to read again then go through it. I just gave the example of humans. अगर एक बच्चा जो है वो खाना खाना चाहे, the task at hand is that he wants to eat something. The performance measure हम measure कैसे करेंगे कि ये जो बच्चा ये खाना खाना सीख रहा है, so we'll have कि ये खाना कितना गिरा रहा है. एक्सपीरियंस क्या है कि वो कितना टाइम ले रहा है उस चीज़ को करने में. सिमिलर थिंग विद द ह्यूमंस. सो इट इज सेड दैट अगर हम कोई टास्क रिपीटेडली कर रहे हैं, सो विद द एक्सपीरियंस ई इफ देयर इज अ डिफरेंस इन द परफॉर्मेंस पी ऑन द टास्क टी, देन वी सेड दैट दिस इज लर्निंग इन द फॉर्मल सेंस. एम आई क्लियर विद दिस? एवरीबडी अंडरस्टूड? नाइस. Now we have to define what this experience means. In tutorial I told you कि experience का क्या मतलब होता है, what is this task and what is this performance measure. Now we have to actually go dig deeper into these things कि ये experience क्या चीज़ है, task क्या होता है, performance measure हम कैसे करते हैं machines में. So all of these has to be formalized. I told you we have to formalize things in order to make machines understand things. तो हम लोग को machines को समझाना है कि कैसे कैसे ये चीज़ें हो रही है. Okay. So now we'll go at what this task T means. So first thing is what is the meaning of a task. If I ask you कि ये एक काम क्या होता है, I just want to take some inputs from you. कि what do you understand by a task? Let's start with Umar. Umar, what do you understand by the task?
So a task is a piece of work.
Any piece of work, let's say. हाँ, piece of work. Let's call it that.
Any kind of work, sir.
Right. Any kind of work, then it again becomes philosophical. Like what do you mean by work? Okay. So if you see that we can say a walking, if somebody wants to walk, it's a task. If somebody is driving a car, driving is a task. If somebody is eating, act of doing something basically, act of doing something which requires some attention or something like that, I can call it a task, I can call it a work. For example, as I said, you gave the examples कि चलना एक task है, खाना एक task है. There are different tasks that we do on day-to-day life, and even we can say act of doing work is also something. Like we don't want to go into the philosophical debates though, but I think you understood what is meaning by the other task. In the machine learning sense, there are also tasks. The first task that we have is classification. If you see, classification का क्या मतलब होता है कि we have to classify something. As we saw, अगर हमारे पास pictures दी जाए dogs and cats की, the thing that we are asked is identify which is a dog and which is a cat. Spam filter, कौन सा mail spam है, which thing is spam, which thing is no spam, and which are dogs, which are cats. there are some classes of the things that we want to identify. ये एक task है. Task at hand is that we want to identify something. Let's go into details of this classification now. Okay. So by classification, what I mean, there is a set of classes. Set of classes. For example, अगर हम dogs और cats के बारे में देखा जाए तो वहाँ पे दो classes हमारे पास है, dogs का cats. तो हमारे पास task in hand था. Task यहाँ पे ये था कि we have to identify dogs and cats से कि image को identify करो. Then in this email वाला filter we had spam or no spam. हमारे पास ये था कौन सी email है जो spam है और कौन सी email जो which is no spam. And then there are other activities. For example, अगर हम hand written कोई ऐसे लिख रहा है 1, 2, 5, 6 तो हमें ये hand written digits है ये recognize करने होते हैं. Then we have 10 classes in that. हमारे पास एक class 1, 2, 3 up to 9 and 0. तो ये सारी classes है basically. Because if I give you a digit, so you have to tell me which digit is it. If I write something like this, you will be easily able to identify that this is a 9. So this is the problem of classification. Okay. So in this classification, we are given some data. So this data will formalize it. What is actually data? We will also formalize this, and then this data we have to actually come up with some machine, with something. Let's call that machine a function. I won't go into much mathematics because I don't assume any background. So we have some data and we feed that data into some function, and then this function should be able to come up with the class. Which class does this data belong to? As I said, in cats and dogs, you have to say whether it's a cat or a dog. In the spam, you have to say whether it's a spam or no spam. In the example of digits, where you have 10 digits, the example at your hand is you will be given a digit and asked कौन सा digit है ये, 1 से लेके 0, 1, 2, 3, 4 up to 0 कौन सा digit है ये. That's the task. So basically we are learning this function. Okay. So in the mathematical terms, if I write it, so हम ऐसे लिखते हैं function which takes Rn मतलब होता है कि जिसमें n input features हो, and it will give me some input of 1 to a, 1 to k. K means like there are k classes. Okay, from this we have two types, broadly two types. The first thing is we have binary classification. Binary classification. I'm going really bare bone basics. I don't expect you to know anything. That's why I'm touching this term. And these are the fundamental building blocks. And these things we'll be using. In the next session, I won't be telling you what I mean by binary classification, what I mean by this and that. So I'll assume that you are paying full attention here and taking the notes as well. So in the binary classification, we have two classes. So if you see this dogs and cats, this is a binary classification problem. If you see this spam or no spam, this is a binary classification task we are saying it. Okay. Can you give me some other examples which is where we have to classify something which is only two classes? Just come up with some examples. Anyone? कोई भी एग्जाम्पल जहां पे हमें दो चीजों के बारे में डिफरेंशिएट करना होता है. फॉर दैट यू शुड कम अप विद अ टास्क.
So car and bike.
हाँ, right. If you have image and probably we have detect whether this is a car and a bike. This can also be a binary classification exam where we have to classify something. Then we have multi-class classification. Evident from the name. For example, if we have to recognize the digits, there is a multi-classification problem because multiple classes. Formally, if I have to write this is a function which takes some input. Okay, it gives the output either 0 or 1. Maybe 0 or 1 means like 0 means dogs, 1 means cats, 0 means spam, 1 means no spam. So, but this multi-classification is, it takes some input data, okay, and it gives the example of k. This is called k class classification problem. So we have k classes in here. K outcomes are possible. So this f is a function. Rn, I'll define that when I go into mathematical details. What I mean by this Rn, there are features of the data. So I think I'm clear with the classification. There's a binary classification and a multi-class classification. In the binary, the out classes, there are only two output classes. There are either 0 or 1 class. For example, cat, dog, spam, no spam, good, bad, yes, no, things like that. Okay. And similar thing, if you have to see multi-class classification, we have to detect some multiple things. For example, if we are given images of cats, dogs, tigers, cows, buffaloes, and we are asked, okay, detect this, then it will become a multi-classification problem. We'll take data and it will belong to one of the classes. So this is what I meant by the classification. So for the first task that we defined is the task of classification. Okay, understood? Everybody understood this? Okay, so now while taking this data, because we have to collect this data, sometimes we have missing inputs in this data. For example, अगर मेरे पास एक image है, if you see what is an image basically, let's just digress for a bit to understand what do we mean by data, because we'll be using data term continuously. Okay, what is the meaning of the data? Data, I can say it's a set of features. Set of features. For example, if you ask me, if I talk about myself, data regarding me maybe, for example, what is my name, okay, what is my age, okay, and then my sex, and then probably some related things regarding me, where I am, my residence, my parentage, and things like that. So for example, let me say these are the features. This name is a feature, this age is a feature, this sex is a feature, residence is a feature, parentage is a feature. So all these set of features, they constitute a data point. So if somebody asks me what is data? Data is nothing but basically some information. What is information? It is some set of features. What are features? Then you can give the example. These are the features. And let's take some other example. If you take example of a sentence, I have in the sentence I have words. So in that, words are features. For example, I have there is a bus. So here we have 4 words. So these 4 are the features of the sentence. So this sentence, this actually is a data point. One sentence is a one data point. Okay. So data basically means set of features. So features, you can break them into any features. And in the task, here we should have domain expertise. Domain expertise, by that I mean, अगर तुम कोई प्रॉब्लम सॉल्व कर रहे हैं मेडिकल डोमेन में, somebody just said that we detect heart disease by using machine learning. So heart disease में वो ये पता होना चाहिए कि किन किन चीज़ों से heart disease होता है. For example, we'll see blood pressure levels, then we'll see cholesterol levels, then we'll see sex, then we'll see age. तो ये सारे फीचर एक पेशेंट के बारे में हम ले लेंगे. Then we'll feed this to machine learning model, and then we'll predict that कि एक पेशेंट को कैंसर है कि नहीं. All these things are features. Okay, these things are features. And set of these features, जब हम एक value देते हैं इनको, then we call that a data point. So इसमें domain knowledge होना बहुत ज़रूरी है. So for example, if I have to solve some problem in biology, I should go to a biologist to ask him कि तुम कौन कौन से features देखते हो इन चीज़ों में. Okay? So by data I mean there is a set of features. अगर तो ये feature for example दो features है. For example, I'll just say name and sex. And let's suppose कि ये name, this can be a string. ये तो alphabet होगा. It will be in the English alphabet, or probably age will be a number. Sex can also be a number, because male female we can represent that as 0 and 1. Okay, similar thing in that. So if it is a number, so here you can see I wrote something as R2. R2 means that each data point has had 2 features, and the value of those features are real numbers. Okay, that this all of these things we will learn in metrics, but here I am saying you कि अगर मेरे पास चलो एक if I am talking about a person, let's take 2 features of a person. उसके पास पहला feature, for example, let's say age, and sex. Second feature is sex. Age is a number. Age is a number, and sex is also a number. By number I mean 1 means male and 0 means female. Let's say age is a number. So I can to determine any person, I can say, for example, if I write age and sex, so here I can make a table like this. If somebody has a age 25 and he's a female and she's a female, if somebody has age 26 and he's a male, something like this. So each of this is a data point. In order to represent each of these data point, I can write 25,0 like this. This represents a data point. I can write 26,1. This is a data point. So that's why in nutshell I'll write it like this: R2. The data points belong to R2. That means each feature is a real valued feature. Each feature takes a real value, and then there are 2 such features. If I write Rn, what's the meaning? That each feature is a real valued feature, and data point has n features. Am I clear with what is the meaning of data in our sense, in the machine learning sense? What is the meaning of the data? When I speak of the data, you should get this thing into your head. Oh, he's speaking about some features. There will be some features, and these features will take some values. Some features will take some real number values. Some features will take strings as their values, like a name, residence. Some features will take some symbols as values or something like that. Am I clear with this? This is what I mean by data. Okay, so why did I make you this? Because in this thing we had classification with missing values. So because when we collect this data, क्योंकि data collection is the first process, अगर हमें कोई machine learning चीज़ें करनी है तो the first thing that we have to learn is we have to see data, हमें data से सीखना है. So sometimes when we get this data there are some missing values. अगर हमारे पास कार का डेटा है फॉर एग्जांपल, अगर हम कार का टेम्परेचर चेक कर रहे हैं एंड देन प्रॉब्ली हम लोग कुछ और चीज़ें चेक कर रहे हैं कि उसका शाफ्ट पावर कितना है एंड थिंग्स लाइक दैट, एंड समटाइम्स वो सेंसर ही बैठ गया एंड देन वी आर अनेबल टू गेट द डेटा. यू अंडरस्टैंड माई पॉइंट. एंड समटाइम्स क्या हुआ कि वो सेंसर जिसे हम डेटा लेना स्टार्ट कर रहे थे वो सेंसर बैठ गया. इन द केस ऑफ ह्यूमंस इफ वी टेक द डेटा बेस्ड ऑन जो उन्होंने घड़ी पहन रखी होती है रिस्ट पे, स्मार्ट बैंड्स, फिटबिट्स एंड थिंग्स लाइक दैट, समटाइम्स ह्यूमंस विल जस्ट रिमूव दैट बैंड एंड ही वोंट फॉर एग्जाम्पल वेयर दैट बैंड फॉर सर्टन टाइम. तो उसके लिए उस टाइम तक हमारे पास डेटा होगा नहीं. तो वील हैव डेटा एंड वील हैव अ टास्क दैट हमें क्लासिफिकेशन करनी है, बट सम डेटा पॉइंट्स देयर विल बी मिसिंग वैल्यूज फॉर सम फीचर्स. So we have to deal this classification as well. That's why there are different algorithms. How do we deal with this classification with missing points? Classification with missing inputs. There will be probably some inputs will be there and there will be some missing inputs. So we have to find those functions कि हम इनको अब कैसे map करें. Okay, like these things are sort of similar because in both the things we are doing classification, but here we have some missing values or missing inputs we have in the second setting. We'll deal with this problem as well. I'm just in that section because we are trying to understand this definition. If you see, so we had three terms here. We had the first is task, then we wanted to see what is the meaning of performance and what is the meaning of experience. We want to see, like in the machine learning context, what is the meaning of task. The first task we saw is that the task can be a classification type. We had to classify, and then we saw there is this binary classification, multi-class classification. In the classification then itself, we saw there can be classification with the missing values or missing inputs. I'll say कि वहाँ पे कोई किसी device ने data लेना बंद कर दिया. There are some improper values as well. The second thing is there a regression task एक होता है. What I mean by regression is, I'll just write it here. Regression. Till now I told you I had set of classes जो मुझे detect करनी थी. So I had the set of classes. In case of dog and cat I had two classes. In case of handwritten digits, so I had 10 classes. तो मेरे पास 10 classes थी total में. ऐसे ही अगर मैं example लूँ dog and cat वाले example, तो उसमें मेरे पास दो classes थे. But there are sometimes predictions, classification based models जहाँ पे ये value जो है it can be uncountable infinite. By that I mean, for example, temperature can range from anywhere to anywhere. Basically, like theoretically speaking, temperature can range from -infinity to infinity. We can have any sort of temperature. तो अगर मुझे prediction करना है कि कल को कितना temperature होगा, it does not have specific class. It can be 25, it can be 25.1. It can be 22.02, it can be 21.05, something like that. So can you see that here we don't have number of classes. तो यहाँ पे क्या है, एक continuous value ले लेता है. So we call it continuous range. हमारे पास यहाँ पे continuous range है. So when you are predicting something, तो हमारे पास classes नहीं है basically. हमारे पास अब ये नहीं है कि हमारे पास सिर्फ 2 classes, हमारे पास 10 classes, हमारे पास 20 classes, नहीं. हमारे पास अब range of values है. It can be anything. Basically we have infinite values. तो हम ये क्लासिफिकेशन भी करना चाहते हैं. एंड जस्ट गिवन एग्जांपल, टेम्परेचर प्रिडिक्शन, even age is also a regression problem. Why? Because age can be from 0 to anything. Age can be to infinity. I'm not just speaking about the human age. You may say, for example, humans can be only till, let's say, 150, but I can say age can be 22.1 days as well. So this is a continuous value, if you understand my point. So here if I write it mathematically, so I mean there is a function which may take some real values and it may have any features. This is the data point basically. If I say this is the data point, the function by function, but like there is definition of the function, but mathematically just think it as a machine. This is the machine basically. It takes some input, gives an output. So I have a function which takes data points. Data point has n features, and what it gives a real number back. It gives some real number, for example -infinity to infinity, anything. Mathematically this is what I mean by a regression problem. This is what is regression. Am I clear? Are you understanding? I'll just speak a random name. Let's say Mahvish. Are you understanding? Unmute yourself and you can say yes or no. Okay.
Yes, sir.
Okay, so first thing that we dealt was classification, and then we saw classification with the missing inputs. Then we saw regression. By regression, I meant that there can be infinite number of classes. By infinite, I mean it can take any real value. So that's why I wrote a mathematical function right here, and which says I have a machine, let's say a function, which takes some data point, which is n features. All these features are real valued features. Then by using that function, I'll implement that function and I'll get a real number value. Example is temperature, prediction of temperature. So I'll get a real number value, for example, some 22.3 degrees centigrade, some 28.9 degrees centigrade, something like that. So this is what is called as regression. Then the other task that we have is transcription. Here I have mentioned it, transcription. Just tell me when to stop if you are feeling like, well, this is getting like really prolonged or something like that. Just stop me there. Transcription, because I want you to get really good at your basics, because next day I'll speak, we have a regression problem at hand. I don't want to tell you what regression means. Next time I'll tell you this is our data. By data you should have that in the head. Oh, data means we have a set of features. That's why I'm giving some more time on these basic terms. In the transcription of what is meaning of these transcription tasks. For example, if you see speech recognition, what is meaning of the speech recognition? So if somebody is speaking, for example, I'm speaking English, and any other person, he is not able to understand English. Maybe he speaks Chinese. So machine has to sort of understand my speech. So it has to recognize my speech. So that's what I mean by speech recognition. And from the speech, maybe I have to create some English transcript, subtitles or something. English subtitles, say. This is actually a task. From the audio, you have to generate a text-based subtitles. So this is transcription. Or let's suppose from a video, we have to create a script out of it. Okay? And even if you see, there are reverse things as well, if you see like that. For example, if you now give a prompt and we can create video out of these. This is reverse transcription. So you are giving something and you are creating music out of that. Similar thing is transcription means that you have a task, you have something, and you want that to be in the textual form or some discrete form. If you are watching a video, for example, and you have to write the summary of that video. Even right now you are doing transcription. You are listening to my lectures, you are listening to what I am talking, and you are trying to note it down. That's actually a task of transcription. Okay? In some machines we have to do it like that. In YouTube you will see कि video आ रहा है और नीचे subtitle भी आ रहा है. That's actually done by machine learning. वो subtitles आ रहा है, that is done by the transcription task. Okay? And every major company using it, Microsoft, IBM, Google, I think most of these companies, they use these transcription methods. And nowadays in the meetings also, so they have some live subtitles, they take notes and they highlight important points. All of these comes in this transcription wala part. So here, just to give you the big picture, we are defining what is a task. So the task definition was done. Then we saw what kinds of tasks are there in machine learning. The first was classification. Then we had classification with missing inputs or missing values. Then we had regression task. Then we had transcription. Then we have machine translation. Machines have to translate as well. And it's really difficult job to translate a thing. Okay? Machine translation is also a task. If you have to change my English language into Chinese that I just said. So this is machine translation. For example, here you will take an input sentence. Okay? If you try to just translate word by word, it will give different meaning. Okay? For example, my name is Musawwir. This is a name. If I want to convert it to Urdu, so if I do word by word translation, my means mera, okay, name means naam, is means hai, Musawwir. So I'll say mera naam hai Musawwir. So it is also like some sort of thing like that, but word to word translation, we cannot do that all the way because sometimes it won't make sense. अगर मैं एक बड़ा सा sentence ले लूँ और उसको word to word translate कर दूँ, then it won't make sense. We have to put the words in the right positions. Okay? For example, I'll say I speak French. I speak French. Let's say I speak French. If I do the word to word translation, so मैं बोलता French. it doesn't make sense. So it looks like क्या ये इसको बोलना भी नहीं आ रहा, तो मुझे ऐसे में like when I translate to Urdu it should be like मैं French बोलता हूँ, something like that. You have to change the order of the words. So you saw there is some like very subtle difference in translation. You cannot translate word by word because it will give different meaning. Okay. For example, if I say there are also like language is so complex. If I say this is cool, कि मैं किसी को बोल रहा हूँ this is cool, अगर किसी ने पूरी डिक्शनरी पढ़ी वो बोला क्या ठंडा है, but there are something called figure of speech. So figure of speech में उसका मतलब होगा कि something is looking good or something is happening which is good, or it is puffing, it's cracking, and there are various figure of speech. कभी कोई ऐसा बोलता है, अगर कोई क्लास में बहुत लेट आ रहा है तो उसको हम बोलते हैं कि बहुत जल्दी आया यार, तो हमारा sarcasm होता है. There in language there are a lot of details, lot of intricacies that we have to look upon. So it's a huge big task of machine translation is actually a very difficult task as well. So वहाँ पे हमें word order matter करता है, वहाँ पे figure of speech matter करते हैं, और बहुत सारे ऐसी intricacies matter करती है. So this itself is a big task, the machine translation. Then we have structured output. So why am I going this way? For example, if you see like this here in the classification itself we saw that classification में हमने देखा कि there were binary, multiple classification, then we went to regression, then हमने देखा transcription machine learning may be a transcription as well, and structured output as I said similar thing happens in the language itself. You have to give a structure of the output. अगर तुम्हें for example कोई image है, if you have to construct an image, और अगर कोई इंसान है वो उसका सर ऊपर है और देन इट है बॉडी और उसके पास लेग्स, इसमें एक स्ट्रक्चर होना चाहिए इमेज में. इट शुड नॉट बी लाइक कि एक मशीन ऐसी इमेज क्रिएट कर देगा कि सर नीचे होगा और टांगें ऊपर होंगी, और फॉर एग्जांपल फेस पे नाक यहाँ पे साइड होगा, बीच में कान होगा. यू सॉ द डिफरेंस द स्ट्रक्चर. तो यहाँ पे टास्क है फॉर द क्रिएशन ऑफ एन इमेज, तो वो क्रिएशन ऑफ एन इमेज में स्ट्रक्चर बहुत इंपॉर्टेंट है. सो दैट स्ट्रक्चर machine should understand. So structured output is necessary. So I am talking about structured output. स्ट्रक्चर्ड आउटपुट में जैसे मैंने एग्जांपल दिया ह्यूमंस का, जैसे मैंने एग्जांपल दिया या इवन लैंग्वेज का, कहाँ पे वर्ब लगना चाहिए, कहाँ पे नाउन होना चाहिए, दैट इज अ स्ट्रक्चर. अगर ह्यूमंस की एक इमेज है या किसी पेड़ की एक इमेज है, वी कैन नॉट मूव पिक्सेल्स हियर एंड देयर, it should be in a well ordered form so that the output should be structured. So this is also one of the tasks. A structured output be a task, we have to get the structured output out of it. Then we have anomaly detection. So we have dynamic classification, class missing value, regression, transcription, machine translation, structured output. Then we have anomaly detection. What do you mean by anomaly? If something is out of normal, basically abnormal. If something is abnormal, anomaly detection. So where did I write that? So your machine here. So if I have some anomaly detection. Okay. So for example, मुझे ये देखना है कि कौन सा ट्रांजेक्शन फ्रॉड है. फ्रॉड मीन्स इट्स एन एनोमली डिटेक्शन. मैक्सिमम ट्रांजेक्शंस ऐसी होती है जो सही ट्रांजेक्शंस है, बट सम ऑफ देम आर फ्रॉड, तो वो मुझे डिटेक्ट करना है. सो दिस इज एनोमली, मुझे डिटेक्ट करना है कि कौन सा वाला फ्रॉड है. एंड समटाइम्स देयर कैन बी थिंग्स लाइक फॉर एग्जांपल लेट्स टेक अनदर फ्रॉड एग्जांपल. फॉर एग्जांपल अगर हमें ये चीज़ डिटेक्ट करनी है कि सभी चीज़ें फ्लैग्स है, इफ एवरीथिंग इज अ फ्लैग, फॉर एग्जांपल कंट्री का फ्लैग है, एंड सडनली कोई बॉल की इमेज आती है, बॉल इज एन एनोमली. इफ यू आर लुकिंग फॉर अ टास्क एंड समथिंग इज आउट ऑफ नॉर्मल, दैट्स व्हाट आई मीन बाय एनोमली. एंड समटाइम्स वी हैव डिटेक्ट दीज एनोमलीज कि ये फ्रॉड ट्रांजेक्शन है, बाकी सब तो नॉर्मल, ये फ्रॉड थी, ये ट्रांजेक्शन फ्रॉड है. तो वैसे ही सिमिलरली इफ यू आर परचेजिंग समथिंग, और तुमने नॉर्मली क्या है, एक बंदा जो रहता है वो ही इज living in Japan and he does not have access to, let's suppose, some particular cloth, silk. If he is trying to buy silk, this is an anomaly. Sometimes we have to detect, okay, ये जापान से कैसे silk ले रहा है, then probably there is some terrorism or something going on. This is how actually people handle this problem. So they try to detect these anomalies. जो चीज़ें normal नहीं है वो कैसे detect करेंगे. Like fraud is the best example of this. If something is happening, even in the medical sense, most of the people they don't have disease. So अगर उसमें कोई anomaly दिखा कि यार this patient has some defect in lungs, तो उसमें कोई defection दिख गया lungs में, तो we'll say तो इसके lungs में anomaly and probably he'll be labeled as cancer or something. So anomaly detection is again a task. Then we have, I'll see it, then we have synthesis and sampling. But this is again a nice task that which usually LLMs do, synthesis and tasks and synthesis and sampling. By this I mean if you ask a machine to generate something, generate a story, write a poem, or ask it a question, give it an answer, it had to synthesize that output. Okay. By sampling I mean, for example, out of these 10 objects, pick 5 objects. So this is also a task. Okay, so I'll just briefly tell. Synthesis means if you want to generate something. Sampling means if you have to sample something. Then we have other things like imputation of missing values. I think this is getting a lot boring because we are getting into a lot of tasks that I think you'll get into project. Then we have denoising. Then we have density estimations. I'll just go through over it, and when we will have such problems, we will get to know what these mean. तो सिंथेसिस में जैसे मैंने बताया कुछ सिंथेसाइज करें सैंपल में कोई चीज़ को सैंपल इम्पुटेशन ऑफ मिसिंग वैल्यूज क्या होता है कि हमारे पास कुछ वैल्यूज ही नहीं है ना वी हैव टू पुट सम वैल्यूज इंस्टेड ऑफ दैट इन फीचर्स बेसिकली जो हमने फीचर्स कलेक्ट किए डिनॉइजिंग का मतलब ऐसा होता है कि तुम्हारे पास फॉर एग्जाम्पल इफ यू हैव अ वेरी लो क्वालिटी वीडियो अगर तुम्हारे पास बहुत ही लो क्वालिटी का वीडियो है एंड यू वांट टर्न दैट इनटू हाई क्वालिटी वीडियो दैट्स आल्सो टास्क दैट्स आल्सो डन बाय मशीन लर्निंग तुम्हारे पास नॉइज है वो नॉइज को रिमूव करना है फॉर यू हैव ऑडियो इसमें बहुत सारा शोर आ रहा है तो यू हैव टू क्लीन दैट ऑडियो देयर आर टास्क लाइक दैट जहाँ जिनसे ऑडियो हम लोग क्लीन करते हैं so changing something which is of low quality into high quality. Then there is density estimation which is a little bit mathematical which we will cover when we will go into that mathematics. So we covered this task. What is the meaning of the task? Is everybody understanding where are we? We're actually trying to do what are the tasks that a machine learning is able to do. Everybody with me? Okay, so you are not sleeping at least. तो हमने अभी तक क्या देखा कि कौन कौन से टास्क है जो हम मशीन से करवाते हैं सो व्हाट आर द थिंग्स दैट मशीन्स आर एबल टू डू देयर वी सॉ अ लिस्ट ऑफ टास्क अ लॉट ऑफ टास्क आई डोंट थिंक देयर आर मोर देन दिस आई ट्राई टू enumerate most of the tasks maybe there are few here and there but most of the things that we will be dealing in our projects will be this it will be a classification problem either classification with missing input या transcription होगा machine translation होगा you have to produce structured output sometimes you have to detect anomaly sometimes you have to synthesize something sometimes you have to impute by imputation I mean like you have to fill in missing values sometimes you have to denoise sometimes you have to estimate the functions so these are the tasks that we will be usually seeing then comes our experience in the experience there are learning experience okay what is meaning of the experience so should we stop here or should I go on because this again will take some time just unmute yourself and ask yes hello not able to hear anyone is anybody there am I audible
Yes, sir.
yes so should we stop here
Yes,
or
sir.
should I think we should you can take a break of 10 minutes probably if somebody is Omar is saying that we can take a break of 10 minutes because it was a mouthful is everybody making notes I just want to interact with you without this so कौन notes बना रहे हैं मुझे तो पहले ये बताओ so Zubair है वहाँ पे Riyan is making notes nice Zubair where is Zubair I want you guys to interact not just raise your hands Amir तुम notes बना रहे हो
Yes, sir.
nice Mahvish
Yes, sir.
so सब कुछ समझ आ रहा है ना कि am I speaking too fast slow are you understanding the things I think rest are not understanding only Riyan gave a thumbs up now everybody is starting Jahangir are you there oh I think he's there yes so some of the people they were not able to attend because some people had fever and some were not feeling well so they messaged me that we won't be able to attend so they'll probably see this recording of the lectures and also I have to do one more thing Zubair so because your friends most of them requested the timing change so do you think we can change the time like is everybody okay with the 7 or because these people they wanted to change the time to 5 there are I think probably 5-6 people were there who asked me can you please change the time because they're having some clashes with the other courses or some things like that तो 5 बजे is it okay कि हमारा टाइम ठीक है 7 बजे is good what do you say
7 बजे ही ठीक है
okay
जी सर 7 बजे ठीक है 5 बजे ज़्यादा जल्दी हो जाता है
बजे ठीक है
सर 7 बजे के बाद
It's fine. 7 to 9.
Okay. Most of the people are saying the 7 is 5, so we cannot like take other people's opinion because they wanted the class to be at 5 क्योंकि उनकी कुछ और क्लास होती है 7 बजे. So they are requested me क्या हम ऐसा कर सकते हैं कि हम classes को shift करेंगे 5 बजे. So I told them I'll probably discuss with the people that are in the session. So these people, as most of you are okay with this, so हम लोग अभी 7 बजे ही रखते हैं, okay? So 7 बजे is done. I'll just convey to them like you can find some time at 7 if you want to join. Okay, so we'll do it at 7. Are you thinking that you are learning something कि ऐसे ही कि मैं बोर कर रहा हूँ, I'm having some laughing gas and I'm spreading that तुम लोगों को हंसी या नींद आ रही है, whatever. Are you able to understand? Just give thumbs up or even unmute yourself. I want you guys to interact because by interaction you will ask questions. Because without the interaction you won't be able to ask me questions.
Sir, one question I had.
Yes.
Sir, you said that they changed the name of AI into ML to gain like the funding and all, but
Yes.
in the graph it is like in the graph it's there like machine learning is actually a subset of
Yes,
AI.
yes,
So
it
these are
is.
two contradicting things.
No, it actually, the thing that you pointed out is actually a good thing. So in the graph, it is a subset. So because they were first focusing on this AI, the broader sense, which I said, they wanted to, from the top down, from the humans, they wanted to create some other humans. So what happened actually is when they came up with the paper, as I showed you the name of the scientist, they came up with the paper that you cannot do it with the perceptrons. So then they changed, we should not start with the human. We should start with some basic tasks like classification and things. That's why this machine learning came in. So we'll use some statistical techniques. We'll use some other techniques. Whatever is there in machine learning is there in AI. But this name change was basically on purpose, because if you see politically, if you name it again as AI, then the problem will be you know that AI won't work because of this. So they call it, actually AI is a huge thing. So we don't want to do that huge thing. We'll do a subset of those things by using that statistical techniques, and we'll do that bottom up. By bottom up I mean we'll start with small tasks and slowly we'll progress and we'll try to create human brain. And in the artificial intelligence, they actually made promises. We'll create armies of robots. We'll do this and that. And there was a lot of hype because of that. And then you also, in the funding domain, you also have to be tricky what to say. And right now, if you see that quantum is getting really hyped up, or quantum, because I work in that, it does not have the potential which they claim it has. कि ये कर देगा. Probably we'll fly with quantum. हम लोग ये करेंगे quantum से, but we know what is it able to do. But they still hype it up because to gain a lot of funding. And I just had a meeting with Rice University's professor, I think yesterday. So he came here to take some people as the full-time engineers for his company. The point he had that quantum is taking up, we have to do something in quantum so that we won't leave out. That's the whole scenario of funding. So that's what I told. Artificial intelligence was top-down, creating humans and then like humans like things. Then they saw it's a big and difficult task. So it's better that we'll start with machine learning. By using some statistical techniques, go bottom up, go with smaller tasks, and then probably try to mimic human brain. And then even deep learning, in that what we do is that we'll see in the deep learning stuff. So actually, yeah, you were right that ML is a subset of AI. Nice question. I hope that it cleared a bit of things.
Yes, sir.
So are there some other questions on those lines or some things like that? Even it can be a random question. Don't think कि कोई question stupid होता है. You can ask any question. I don't mind. I said in the session 0 that you are here to learn. कि चाहे ये कितना ही ऐसा question हो कि you feel like people will laugh at me कि ये क्या कौन सा question है, maybe I don't understand this. So it's okay if you ask a stupid question. I am willing to answer that. I am willing to put in the efforts. But the thing is कि तुम्हें question पूछना है. You should ask the question. And sometimes maybe I am also wrong. It's not that I have read something and I am always right. Probably you can correct me sometime कि नहीं भैया मुझे ऐसा लग रहा है sir, I am feeling like this. So can you please shed some light on this? So I want this to be like the session like that. ताकि जो learning वाला part है that we can maximize. It's not कि बस मैं बोलता रहा हूँ तुम सुनते रहो. It's just one way communication. As Riyan asked a really good question कि he felt कि ये तो contradictory हो गया. If we did same thing in the AI and ML, then why is it a subset? It actually was a good question. Like it was a thought-provoking question. ऐसा क्यों होना चाहिए? Okay, let me just randomly start. I'll start with Jahangir. Jahangir, what did you understand by classification? बाकी लोग को तब तक रेस्ट मिले. Is Jahangir there? I think he is not. He's unable to mute. Also, Umar, what do you understand by multi-class classification?
Yes, sorry, I was unable to mute.
Okay. Can you just talk what is meaning of the classification?
So we have different things in classification, multi-classification and single classification. Simply we classify the data in different things. Like in classification, we differentiate the data in 0, 1 or 0 in binary form, binary classification. And in multi-classification, we have much data like
We
in
have many
graphs,
classes.
graphical.
You should have understood it. You'll again revise it a bit and you will understand it. Nice. And you understand it, but it's good that if you are understanding 80% of what are the things that I say, you can rewatch the lecture and probably revise your notes as well. Because why am I emphasizing this much on these basics? Because in the next session, I'll be just we're taking a data. So this is a classification, binary classification problem. So I'll assume that you know all of these terms. So that's why you should also go home, revise, and then see your notes, things like that. Because tomorrow again we'll be taking the session, and there we will probably discuss some algorithm. We'll start with Python basically or something like that. I'll tell you upfront. So Umar, can you tell me what have you understood, let's say by regression? Because these are famous things that you must know. In that way you will also revise and other people will also get to know. What do you understand by regression? Is Umar there? Come on boys, interact, yeah. I actually asked you, what do you understand by regression?
You just stopped.
Okay. Did I reconnect it back now? Am I audible? Hello. Yes.
Yes, sir, you are now, but still you are stopping me.
Audible, sir, you are audible.
My screen is visible and is the screen moving?
Yes, sir.
Okay. So I was just asking you the question, what do you understand by regression? I called out Mahvish Qadir's name. Can you just explain what do you understood by regression? You can see it here.
बेसिकली ये प्रिडिक्ट करता है रिग्रेशन की वजह से, जैसे हमारे वेदर प्रिडिक्शन होता है, ये मतलब क्लासेस से चलता है और इसकी कंटिन्यूस रेंज होती है। जैसे हमारी वेदर प्रिडिक्शन वो कंटिन्यूसली चलती रहती है,
Nice.
जैसे एज की प्रिडिक्शन वो कंटिन्यूसली चलती रहती है।
Nice that here we don't have set of classes, like हमारे पास सिर्फ 5-6 classes नहीं होते, we have continuous range of values, हमारे पास बहुत सारे values होते हैं, तो then we'll talk about regression. Okay, is everybody fresh now? Can we start with this experience वाला stuff?
Yes, sir.
Okay. So now we are done, at least we have some understanding कि ये task क्या होता है, कौन सा task machine learning के साथ, जैसे मैंने बोला classification हो गया, regression हो गया, then we have transcription, then we have these generation, synthesis, ये बहुत सारी चीज़ें होगी। तो now we'll see कि experience क्या होता है, what do you mean by that word experience E? In the setting you learn by different ways, कि हम जो सीखने के तरीके वो बहुत सारे होते हैं। The first thing is that is supervised learning. Okay, I'll write it here. Supervised learning. अगर मैं इंग्लिश सेंस में बताऊं व्हाट इज द मीनिंग ऑफ सुपरवाइज्ड, सिंपली पुट कि समथिंग इज वाचिंग यू,
The screen is not visible. Hello.
Yes. Is it visible now? Is it visible?
Yes, sir, it is.
It is visible for everyone.
Not yet.
I think for you, Salim Jahangir, you have some problems. Are you able to see what I am writing? Zahid?
No, sir.
Yes, sir.
Yes, sir.
There is a problem with you, Jahangir. You have some network issue. Can you please reconnect and then?
Okay, sir.
Okay, so we have supervised learning. So probably Jahangir also will like to see the recordings as well. So by supervised learning, I mean, I was talking about what is the meaning of supervised. Supervised means if somebody is looking after, for example, where in the exams we have supervisors. Supervisor means somebody is guiding, there's a guiding principle or something. Similar in the learning, as I talk about, I just had a conversation with you about data. What is data? Data has two things. Now if you see cats and dogs, I have data as images. Okay, with the image I have labels as well. Okay, for example, I had an image like this, some image was there and it was labeled it's a dog. There was another image and for example it was like this and it was labeled it is a cat. There are two things to each the data point. It is having these set of features, then a label. Okay, so if I talk about these handwritten digits, if I wrote some things like the one, it is an image, for example, it is labeled as one. There is a label as well written on it. So when you feed, when a learning algorithm works, learning happens in such a way that it takes data plus label as an input. So we call it a supervised learning. So for example, cat or dog के example में, if we give image plus labels, labels का मतलब ये image cat है, ये image dog है, with the image we are giving labels as well. तो हम उसको कहते हैं कि ये supervised learning में रह रहा है. So okay, so let me talk about this mathematical setup. So setup क्या है यहाँ पे, हमारा data कैसा दिख रहा है अभी? So we have some data set D. In that we have pair of things, xi's, that is a vector, for example, in which we have some features. Let's say we'll start with x1 is a data point and we have a label corresponding y1. Then a second data point we have x2 and then it has a label y2. Similarly we have, let's say, m data points, xm, we have m number of data points and we have a label corresponding to it. So this is what I mean by supervised learning. In supervised learning we have data as well as its labels. So what is the thing? This x's, xi's, they come from some set x for a set of images in case of dogs. In case of spam filters, they come from a bunch of emails. And these y's, they come from, for example, a subset of y. That means some labels, spam, no spam. So in the upfront we have a set of data points with the labels, and if the learning is done in that process, it's called supervised learning. Supervised में ऐसा होता है कि हमारे पास डेटा भी है, उसके लेबल भी corresponding है. तो then we feed these things to the machine कि ये image dog की है, ये image cat की है, now learn, कि हम लोग इसके बाद उसको कोई और डेटा पॉइंट देंगे. We'll don't give the labels. In the testing phase हम लोग सिर्फ एक्सेस देंगे, उसके बाद we'll say बताओ ये वाली इमेज अब कौन सी है. For example, if we learn, अगर हम जब बच्चे को पढ़ाते हैं, we'll say this symbol is A, this symbol is B. Then we'll say okay, identify these symbols in this. This basically is a supervised learning. In the first case you showed them the data and the labels as well. But when you were testing, तो तुमने एक set of symbols दे, बोलो चलो इनको identify करो अब. Okay? So is supervised learning clear? What is it? We have data points with the labels and we feed that to the machine. And whenever a prediction is made, it is made based on the labels and the data that we saw. That's called the supervised learning. So I was talking to supervised learning. We have data points for the image as well as labels in there. Data plus label is fed into the machine learning, and then we get the output, corresponding output out of it. And we get a machine learning model in which we'll feed new data and then we'll get the prediction. So in a setting in which we have data plus labels, that's called supervised. So unsupervised, it means we have just data, we don't have labels. We don't have labels. Okay? There are no labels, there is data only. So there are algorithms which work on the supervised setting. For example, support vector machine is an algorithm. There are k nearest neighbor is an algorithm. So these algorithms, they work on supervised setting where they have data as well as the label. So for example, unsupervised, there are algorithms like clustering. There are no labels. For example, we are given a bunch of patients without telling that which of them have cancer. We try to find clusters. Okay, we find clusters like this. There will be a cluster like this, and the other cluster will be like this. So if we find two clusters without even knowing the labels initially, so then we can say this cluster of patients have cancer and these don't have cancer. This is called unsupervised learning. In the unsupervised learning, what do we have? We have just data points. So we have like this x1, x2, these are the points, till xm if there are m data points. There are no labels with it, and we've tried to find the clusters, or we try to do some learning without the label. This is without labels. That's why it's called unsupervised learning. Okay. Then we have what's called as reinforcement learning. In the reinforcement learning, it basically takes a feedback. So for example, how do humans learn? They use a mix of all of these things. Reinforcement learning means there is, for example, an agent. Agent means a person or some machine which wants to do something. So if it performs an action, then it gets some reward. And if, for example, if it has to identify something and it felt, oh, I'm doing it correctly, so it will again do that. So it will take some sort of feedback. If it does some task, it will be reinforced. The decision will be reinforced. I don't want to go technical term. There are something called exploitation, exploration. I just want you to learn reinforcement learning means it is actually taking inputs from the previous outputs. For it something happened, it will take it as feedback. It's not just we'll just stop it like we did something and based on the data only. So here data is also there, but there are also functions. For example, by doing this thing I got this much of reward, or for example by doing this thing the reward was negative, so I don't do this, I should not do this move often. So actually feedback is there. So here you can just write there is a feedback. And we have something called as exploration of states, exploitation. This in itself is a huge field that's called reinforcement learning. Like there are something like some other even core subjects which have been taught in this reinforcement learning. Then there are something called as reinforcement learning by human feedback. There are some things like that. By reinforcement, I just wanted to convey that in reinforcement learning हमारे पास एक agent होता है, it performs certain actions and it gets a feedback from those actions. और उसके बाद वो अपनी actions को correct करने लग जाता है. That's what I mean by this feedback answer. Unsupervised में we have data plus labels. In unsupervised we have just data. In reinforcement learning we have an agent, set of actions, and then it performs set of actions. और उस actions की वजह से क्या होता है? It tries to make its decisions better. So now we know what is an experience है. हमारे पास टास्क भी आ गया, टास्क क्या होती है, कितने कितने किस्म के टास्क होते हैं. Now we saw कि कैसे कैसे चीज़ों को सीखते हैं. There are ways of learning. कि supervised setting में सीख सकते हैं, unsupervised setting में सीख सकते हैं, reinforcement learning के हिसाब से सीख सकते हैं. Now we have to measure it कि अच्छा ये तो learning तो मैं बोल रहा हूँ कि ये अब perform कैसा कर रहा है वो मुझे देखना है. There are a lot of performance metrics. The only thing I'll talk is accuracy or error rate. So while we'll go with your projects and other things, we'll slowly learn about other measures. Accuracy means ऐसा होता है कि अगर मेरे पास 10 पेशेंट्स थे, 10 में से अगर 10 were diseased, अगर 10 में से फॉर एग्जांपल let's say 7 डिजीज थे और 3 जो थे that were नॉन डिजीज, अगर मैंने कोई एल्गोरिथम लिखा है, I trained a machine learning model, और मशीन लर्निंग मॉडल को अब मैं ये एग्जांपल्स फीड कर रहा हूँ कि मुझे बताओ इनमें से कौन सा डिजीज है. फॉर एग्जांपल लेट्स सपोज कि ये इन 7 में से ये 6 को डिजीज बोल रहा है, दैट मीन्स 6 प्रेडिक्शंस वर राइट, ओके, 1 वाज नॉट राइट among those diseases, और 3 में ये 3 को नॉन डिजीज बोल रहा है. That means it made one mistake. That means the accuracy is 9/10. That's 90% it was accurate. क्योंकि एक ही गलती करी इसने. That is the number of things it got right was 9 out of 10. So we'll say it has a 90% of accuracy. Okay, this is how we measure accuracy. We'll also look at different methods of performance. I'll say one performance measure is accuracy. So there are, for example, other scores like F1 score is there. There are, for example, precision is there, recall is there. Then we have something called as area under curve, RUCs. There is something called as root mean square, RMSE error. There is something called as MSE error only, the absolute mean square error. So there are a lot of metrics that we will see how to measure these performance. क्योंकि अगर हम अब कोई टास्क कर रहे हैं, we need to see कि सही में जो ये टास्क करने वाला है with experience क्या है, बेटर हो भी रहा है कि नहीं हो रहा है. Okay, so that we have to perform. So I just gave accuracy is one of the measure जहाँ पे हम देखते हैं कितनी prediction सही हुई और कितने prediction, because no algorithm on the world will be 100% accurate. कोई ना कोई गलती, if it is 100% accurate, it's memorization. It's trying to memorize the things. Also wanted to also differentiate between memorization and generalization. That will probably take up in other session. So memorization is not a good thing. That's actually in technical term that's called overfitting. That we will see. So in this session I'll just summarize it before closing. We started with the history, a brief history, how it started, all the things, and then what happened. And then we started with the definition, what is meaning of the task. And then we started, okay, what is mean by this experience E. And then we started with what is the meaning of this performance, how do we measure performance, okay, P. And then in the task we again read a lot of things. So here we in the detail we discussed कि task क्या होता है, then what is the experience, the performance कैसे हम लोग measure करते हैं. It was actually to justify this definition basically. कि हम जो definition पढ़ रहे थे कि with the experience, where is that, हाँ, right here. A program is set to learn from experience. एक program को हम लोग कह सकते हैं कि it is learning from some experience. With respect to some classes, class of task, अगर इसको कोई task करने को दिया जाए तो हम उसकी performance measure करते हैं by using P. तो हम लोग कहते हैं कि ये तब learn कर रहा है जब इसका performance जो है वो increase करेगा, when it will have a higher performance which is measured by P on that task T while it is having some experience, it has some experience E. I think we just covered the basics of what is the meaning of like these terms, because these terms will be the terms जो हम frequently use करेंगे in the upcoming session. I think from upcoming session I'll just delve into the bit of this theory again sometime अगर मुझे चाहिए, and mostly we'll start with the basic Python. हम लोग Python के बारे में I think we'll require one session so that you will be able to code it. और इसके बारे में जितना मैंने ये सारी details बताई, I would probably give you some links as well. अगर तुम follow करना चाहते हो, I'll give some good links to some blogs, to some books also, and to some good videos. जहाँ पे ये तुम्हें लगे कि okay, if we need to revise, if we need to get some good concepts as well, तो मैं कुछ links दे दूँगा. I'll post them in your emails or in the group itself. And the second session, the session 2, we'll have on Python, in which we'll learn fundamentals of Python so that we can code in the next session as well. तो क्योंकि उसके बाद हमें प्रोजेक्ट करने हैं. So second session, be ready for the Python. So if you have any question related to any of these and you want some perspectives कि अच्छा हमने क्या क्या पढ़ा आज, it was a mouthful, I know it was a longer session, तुम लोगों को बहुत सारी चीज़ें अभी रिवाइज करनी है, but I'll say it will need efforts. पहले सेशन में मैंने ये बोला था कि you have to put your efforts, it will need a lot of efforts from you. At least like in a week, you should be able to give 15 to 20 hours. 15 hours should be enough. The more hours you put, the more you'll be able to understand these things. Okay, so if anybody has a question regarding anything. Am I audible? Yes, I think I am, because I am seeing my screen as well here. Okay, so I assume that you don't have questions. It was the first session. It was really nice to again delve into some good concepts that you even sort of understood and things. And I want you to revise all of these and make clear notes for your revisions, and then be ready with the Python for the next session. I hope everything that I said you understood. You can start the discussion in the group as well, because Saturday, Sunday I am sort of usually free. I can take your questions as well. Okay, I'll also provide you the links to study further. Thank you so much. Assalamu alaikum everyone. Hello?
Walaikum salam.
I thought I'm not audible at the end. Okay, bye everyone then.